let's get the collision testing going. But actually, let me have a sidebar first. I realized when I committed the changes from the previous video that there is a little settings icon down here in the commit dialog window thing. If you click that, there are settings. We can apply tons of automated features upon our commits. So you can disable code analysis or change what type of analysis you want to run. I've enabled optimize import, so I stop getting those warnings. And I've enabled reformatting the code so that all my code is consistently formatted throughout the application. I recommend that you do the same. I am curious about rearranging the code and cleanup, but I haven't checked out what they do yet. So I'm going to leave that to you to experiment with, but anything that can be automated is a good thing for a developer. So check this out, consider using it. Now, let's go back to the project. So in our entity, we have our old rectangle intersection test is colliding. Takes two entities, return a Boolean if they do. That means they are overlapping in some regard. Okay, the entities are updated in the level manager somewhere. That's loading, and that's update. There's even a function, a comment to tell us to get this done. So let's call something like check collisions. Create that function. There we go. What does this function need to do? There are an infinite number of ways that we could do this, and we're going to do, as always, the quick and dirty thing first. We walk through all of entities, and we ask them if they collide with the player. Because right now, all we have is static entities, and so the player is the only thing we're interested in colliding with. The static entities will not have collision reaction, at least not yet. Well, they could. Well, whatever. Let's write this out. So, what do we want? We want for every entity in entities. There we go. If they are colliding, if is colliding, entity with the player, what do? We notify them. We have had this part of the interface since day one, I think. There is update render and on collision. On collision gets the entity that we're colliding with and lets each entity decide for themselves how to deal with it. We move the behavior of those entities into those entities, which is good object-oriented programming, not necessarily great game programming, but that's neither here nor there. So all we need to do is entity on collision with player and player on collision with entity. So infinite number of ways of doing this. This is easy, so we're doing it first, and we might later on want to separate types of entities so that we can run the types of checks that make sense. There's no point in checking ground against ground, for example. But if you add bullets, if you add enemies, if you add other dynamic entities, you might want to run those in their own different types of test pairings, and you don't want to do, more tests than necessary. One thing you could also do is instead of looping every dynamic entity and checking it against every other dynamic entity, you might want to do something called spatial partitioning so that you organize, you get sort of lists of potential colliders that are nearby to your entity, and then you only test against those. That tends to be a huge performance win, and I might add that as a pass with distinction achievement on this game. It's not incredibly difficult to write, and there's lots of articles out of the web to read about this system. Spatial partitioning, there are many ways of doing it, doesn't have to be difficult, and it could be fun to write. Anyway, we do simple linear list walkthrough. As I was waffling right now, I realized that we are going to cause a bug because our player is in the entities list. If I'm correct, create entity. If that sprite name is a player, we set our member variable and we add the entity to the list. So we need to filter that out or not keep the player in the list. We could remove them and always treat the players separately, but that seems like more work for now, so I'm going to ignore it. Also, if you're writing in Java, this will not work. You can't compare strings in Java like this. If you're writing Java, you have to do sprite name equals player, because the way they manage strings is different. It's a pain. Kotlin gives us this syntax back like it should be, and we can compare strings regularly. So this will compare the content of these strings, not their references. Anyway, back to the loop. We don't want to test if the player is colliding with itself, because that will always be true and will cause many bugs. So we filter it out. If the entity is the player, just continue. That keyword is misunderstood and underutilized. I love it to bits. What it means is stop processing the for loop here, return back to the top with the next iteration. So unlike break, we don't stop the loop, we just skip the rest of the body. It's fantastically handy. Okay, so we keep that. We keep the entities in the list. The player in the list. We don't have to change anything. What we need to do now is decide what the player reaction is going to be. And to do that, we'll start with some copy pasting. I'm already at the article, but let me go back a bit. So there is an article. When you watch this, there is an article available for you called Axis Aligned Bounding Box Collision Detection, because that's what this system is. This is our previous, well, it's our current collide. What do we call this? It is a broad face. It's not, whatever. It's a cheap rectangle to rectangle intersection test. When this has returned true, we can call get overlap instead to figure out how much are they overlapping and in which axis is the overlap the smallest, because that's the one we want to address. You address the smallest overlap first, so you can move the entities apart the minimum amount to ensure they are no longer overlapping. So that's what we'll do. We copy this code, bring it to our entity, and put it next to is colliding. So it's another free function. It needs the point f object. It needs the abs function. And that should be it. So it returns a point with the x and y, either 0 if there is no overlap on the axis, or some value that we can apply to our position to move the entities apart. If there is no overlap, it returns null. So we open the dynamic entity, we zoom in a bit, we press Ctrl O to override what we inherit from the base entity class. On collision, we call, let's see, variable overlap equals get overlap between this and that. If overlap isn't null, we know that we have something to do. We can simply do x plus equals overlap.x, y plus equals overlap.y. That should move us apart if we got the signs right. You might have to trade these around. You'll test it and notice. One thing we want to do is when you move things apart like this, you also want to stop them from sticking together, because we're moving in the direction of that collision. And so whatever our motion is, we need to reset it. That means we should do a bit of checking if overlap x isn't 0. And now you're shouting at the screen because checking a floating point against a specific value like this is often badly considered. What is the term I'm looking for? It is most often a bad idea. However, we know from our implementation that the value will be 0 if there is no other relevant value. So we can compare to 0 with this particular instance. So if it isn't 0, then do something with it and also set the velocity on the x-axis to 0. So we don't walk straight back into this collision and are unable to get out of it. That's the floating point value. Similarly, if overlap y isn't 0, do the thing, set velocity y to 0. I am inconsistent with how I type my floats. I realize I'm C damaged. Here's another code smell I really don't like. Indentation levels. If you need more than 3 indentations, you're mad. Your function needs to be restructured, rethought, reformatted, whatever. It's probably doing too much. And in this case, it's not going to do any less, but every level of indentation is a new scope. Every scope is a new context that you have to keep track of in your head. Instead of writing your code falling to the left, to the right, to the right, to the right, to the right, try that to make your code stick to the left. It forces you to rethink your scoping. It makes your scopes shorter. And the way you do that in this particular case is you invert the tests. So instead of doing if overlap is not null, use overlap, we ask if overlap is null, just return. We don't have to do anything else in this function. And now all of the code moves to the left. And we provide a, what do we call that? A flow, whatever. We are provided a linear path through the function where we do one thing at a time, and we can just abandon sort of the stuff we've already covered. So after this line, we know that overlap is not null. I don't need to keep that in my mind. Move your code to the left whenever you can. Always consider your branches and change them to the other way if it gets you further to the left. If you still end up going very deep, you probably have a function call that needs to be extracted, or there's an algorithm that needs to be used instead of writing a raw loop, etc. But yeah, consider indentation levels as smells, and more indentations than 3 should be considered an indication of a possible problem. Don't want to overstate the case, because obviously sometimes you got something hairy going on, but try to keep your flow linear. Let's see if this works. We are calling update, right? Yes, we are. Oh yeah, there we are. Excellent. The map is super boring, but we can change the level data a bit, give us some room. That's the test level. Just gonna move that apart, open up the space. Can also give ourselves a bunch more falling, so we have a chance to see that. There we go. Nice. We're on the ground, behaving. Of course, it's difficult to test this before we get the controls in, so that's probably next. We need to be able to walk around. What else do we need to talk about? Handle input. Yep, that's it. We have the delta time. I really want to restructure this a bit, so I essentially want these accessors to be up here instead. I want the run. I want update above render because that's the order I think. You know, input, update, render. So that we can see what's happening. Render looks good. We have a bunch of callbacks we're not using, but we keep those because they might become relevant, especially with input systems, actually. If we're handling Bluetooth controllers and other things, it's good to have the lifecycle callbacks. We are starting the thread in Surface Created. There's been some discussions in the forums that it might be beneficial to move that into Surface Changed, because Surface Changed is closer to where the surface is actually available to us. So there might be that the thread is spinning a bit here before we get to Surface Changed and we have an actual buffer with width and height, etc. However, I think it's this. Yeah. I've been thinking about is running. Having it as surface destroyed before the join call is necessary. It's not going to hurt. But I also want it in on pause, because that happens a bit earlier. The on pause call gets to us before the surface is destroyed. And so we might as well stop processing at once, right? So if we set is running false in on pause, the core loop might have already exited when we get the surface destroyed callback. And so this will happen much quicker. We don't have to wait for another frame. It's just done. So it makes sense to have is running false in both locations. You could join the thread in on pause 2, but will it self join when it exits? I don't know how that works. I should figure that out. Anyway, I'll see you in the next video.